Hello everyone, Assalamu alaikum. This is Sohaib from 10xEngineers. Welcome back. In today's session, I would be giving you a walkthrough of the Infinite ISP project and enable you to get started with it. If you haven't seen the previous video, that is the introduction to Infinite ISP, I recommend that you watch it. So let's get started. So let's search Infinite ISP. So you can find the GitHub's link to the public repo easily in the search results. So let me open it. So you can see the repo is under the Apache 2.0 license. We will see the folder structures and files in details. It has a very detailed README. The first section of the README is all about the complete ISP development stack. You can see the references pointing towards the other public repositories of the complete stack. So the first one is the algorithm design repo. It contains the Python-based implementation of Infinite ISP. It contains the floating point implementation, and the algorithms in this repo are basically chosen based on the image quality results. The repo actually provides a convenient method for comparing those algorithms with each other, and then they can be easily selected based on the quality of the results. Once they are selected, there comes the reference model. In the reference model, we have the fixed point implementation of a chosen pipeline that is chosen based on the image quality in the algorithm design model. The fixed point implementation model is a convenient model to aid the RTL development. Then we have also released the FPGA binaries. The ISP's results over an LCD display or by saving those results in an SD card. The firmware repository is currently under development, it's empty. Then we have the tuning tool. So the tuning tool contains the calibration and analysis tools for the pipeline. So let me open each one of them. So this is the reference model. This would be the focus of our session today. The model, basically this is aiding towards the RTL development. It also contains the complete overview. So we will look into the overview later. Then we have the FPGA binaries. It actually contains the files that can be loaded to the kit to see the ISPs working. And here, these are the instructions on how can we load that binary files. Then we have the tuning tool. So you can see the block diagram of the tuning tool showing what modules are currently supported and what are the analysis tools. And it also tells you how to interact with the pipeline. So let's go deeper into the reference model. In the reference model, you can see the architecture of the complete ISP pipeline. The input raw image is processed by each of these ISP block, the pipeline itself, in 4 domains: raw, RGB, YUV, and finally a selection of YUV or the RGB domain. Then as we move further, we can see the features the repository provides. Obviously, it provides an RTL friendly code that is easier to use for the RTL development. It also provides the feature of test vector generation that actually helps in testing the RTL. It has 2 unique features of dataset processing and video processing. Video processing actually is the feature in which the 3A algorithms are applied to the next frame and they mimic the scenario of a video. Then we have the feature list. In the feature list, you can see the description and summary of each of the ISP blocks that is in the architecture. This section actually tells you how to run the ISP pipeline and use different features of it. Finally, in the results section, we have some images that are processed by the pipeline and compared with their ground truths. So we have a mixture of indoor and outdoor images. We have a comparison of each of them based on an image quality metric. So What we are going to do is we will clone this repo, and I will show you how can we process a single image using the reference model. So let's copy the web URL. I'm going to create a folder in so I have installed Git and I'm using the Git bash. Let's type the command git clone and then paste the URL. So the cloning will take some time. So it's done. Now let me open the cloned repo, and you can see a list of directories and files. The first one is the configuration directory in which the default configuration is placed. Opening this configuration file, and you can see different heads and a number of parameters in each of the heads. So first is the platform head, where you select the image on which the pipeline should be running. Then you can also select if you want to save lookup tables, generate test vectors, or also you can select the format for saving the intermediate results. Then we have the sensor infos head. Because it's a model, you have to provide the information of the sensor. So you can select which buyer pattern you should be using. Also, you can select the bit depth, and most importantly, you can tell the dimension of the input raw image. And then there are all the parameters related to the ISP blocks. Each of them is separated in a different head. You can easily select if you want to enable or disable any block, and you can select on which parameter it should be running. So for example, in dead pixel correction algorithm, you can select if you want to like run it or not. So false. Or if you want to run it, then what should be the algorithmic parameter? You can get a guide of this parameter from the docs. I will show you that as well. The tuning tool actually helps tuning these parameters. So you can run the tuning tool and generate a similar configuration file and direct this ISP pipeline to be using that configuration file. And as a result of which, you will be using the tuned configuration from the tuning tool to run the pipeline. So now let's move to the other folder. The docs folder contains the document that contains an algorithmic description of each of these modules that are selected for the ISP pipeline. So you can see if I go to any of the ISP block, it explains what the algorithm is doing and something about the configuration parameters so that the user can easily choose a parameter on its own. So next is the in-frames folder. In this folder, you can see some of the sample raw images that are placed with the pipeline. The configuration file can be changed to any of these names directly to run the ISP pipeline on these raw files. In the modules directory, you can see the list of files corresponding to each of the ISP blocks. All these files actually contain the algorithms that are being executed in the pipeline. Then we have the out frames directory. In this directory, the processed output frame is placed. We have the test vector generation directory. It contains the scripts for generation of the test vectors. And in the utils directory, we have files that contains the helper functions for execution of the pipeline. So before running the pipeline, we have to install all the dependencies. Uh, the dependencies are listed over here. They're in the requirements.txt file. And the guide also tells you how to get all these dependencies in a single command. So I recommend that you guys use a package manager. I am using Anaconda. I'm going to open Anaconda prompt. Make sure you always run this package manager as a administrator. And now let's create an environment with the create Conda create infinite ISP with the specified Python number, Python version. So let's create it. So the Python version is actually given over here 3.9.12. So I have copied it from there. Now it's creating the environment. So since it is creating a base environment, it requires some of the default packages, and we have to do yes, yes. So the guide says we have to have the pip package manager installed. So you can see the pip package manager is being installed in the base environment. So now let's activate this on the activate infinite ISP. So now we are in the environment that we just created. Once we are in, we can easily copy this command. So before copying this command, we need to be moving to the directory. So let's do it. So now we can like run the copied command pip install requirements. So now it will update this base environment with the list of dependencies that are inside the requirements.txt file. And these dependencies are the ones that will be required for running the ISP's pipeline. So yes, now it has finished all the downloading and installing of the packages. We can minimize it. In order to run the pipeline, you can either copy the Python command from the user guide, or you can use a GUI tool to actually run the pipeline. I'm using Visual Studio Code. So let's open Visual Studio Code and run the pipeline from over there. So once you are in the GUI of the Visual Studio Code, you can go to isppipeline.py and simply run the Python file. So running the pipeline for the first time from the GUI, you might see some warnings. You can ignore them. These are related to Conda, but the pipeline should run without any errors. So you can see that as the pipeline was executing, it gave out some useful information, and the information is corresponding to each of the pipelines block. So for example, in the dead pixel correction, it is saying how many pixels it corrected, and it also shows the threshold at which it was set. Similarly, for black level correction, it is showing that it was like enabled, and then it is showing the binary approximation for the linearization factor that was used. So this approximation can be used in the RTL's implementation. So all the ISP blocks throw out useful information like these, and once it is executed, it returns with the execution time of the complete pipeline. So now let's see the output image. For that, we would be going to the output frames folder, and there is the output image that it processed. Let's open it. So on your screen, you can see the raw image that was placed in the in frames, and now you can see the processed raw image from the Infinite ISP's pipeline. So this was all for this video. In the corresponding next videos, you will be going through some of the features that Infinite ISP has provided. So until then, see you.